In many parts of the world, life goes on as usual. Visitors flock to tourist areas, residents go about their daily activities, and no major changes are visible on the surface. But deep underground, processes are constantly underway. Around the same time, researchers' attention has once again focused on three distinct volcanic regions: Yellowstone in the United States, Kīlauea in Hawaii, and Campi Flegrei in Italy. While the three don't exhibit identical behavior, each offers new clues about how Earth's energy continues to move. Yellowstone is a starting point because it harbors one of the most complex geothermal systems ever studied. From the outside, the region is filled with geysers, hot springs, and seemingly serene landscapes. But deep down, vast geological structures form a network that continues to be studied. Researchers use long-term observations to see how underground conditions change over time. What makes Yellowstone fascinating isn't its size or reputation, but rather the processes occurring on a scale that's hard to fathom. The observed changes are often so small that they are imperceptible to humans. Nevertheless, each shift provides crucial information about how heat and rock interact deep beneath the surface. From this dataset, scientists are building a clearer picture of the evolution of large-scale volcanic systems. Meanwhile, in the Central Pacific Ocean, Kīlauea demonstrates a different side of geological dynamics. While Yellowstone keeps much of its activity at depth, Kīlauea often displays its processes directly. This volcano is known for its repeated eruptive episodes and its ability to reshape the landscape through ever-expanding lava flows. Each phase of activity at Kīlauea provides an opportunity to observe the magma's journey from beneath the surface to the surface. Changes in their path and pressure release patterns are part of research that helps us understand the behavior of active volcanoes. It's in places like these that scientists can see how Earth's internal systems operate in real time. Despite its apparent activity, Kīlauea isn't always associated with extreme events. Many changes are gradual and part of long-term natural cycles. Therefore, the greatest value of observations in this region lies not only in the visuals of eruptions, but in the ability to read the patterns that develop from one period to the next. Attention then turns to Italy, to Campi Flegrei, a region with a very different character. No single mountain peak dominates the landscape, but beneath this vast area lies a volcanic system that is one of the most important objects of geological research in Europe. The region is of interest because it exhibits slow but consistent changes. At Campi Flegrei, the focus of observations is on the surface deformation and underground activity that develops over long periods. Such phenomena require a different approach because the processes are not always directly visible. Data are collected gradually to understand how geological conditions can change without producing noticeable surface signs. Comparing these three sites, it becomes clear that each represents a different way the Earth releases and regulates its energy. Yellowstone illustrates a large-scale system hidden deep underground. Kīlauea demonstrates how material from deep within can actively reach the surface. Campi Flegrei demonstrates that slow changes can still have immense scientific value. To date, there is no indication that these three regions are heading towards a major event simultaneously. However, ongoing observations demonstrate one intriguing fact. The planet is always in motion, even if much of this process is invisible to humans. And perhaps the most intriguing question isn't when the next change will occur, but how many secrets lie beneath the surface, still waiting to be understood.